Trying to predict the products of chemical reactions can be daunting. So let's focus on a couple of rules regarding acid reactions. The first is neutralization reactions, which involves reacting an acid with a base to produce a salt, which is essentially an ionic compound, and water. But remember though, it doesn't mean your end product is neutral. So a typical acid-base reaction is hydrochloric acid and sodium hydroxide, which produces sodium chloride and water. Now, one of the questions commonly asked is, how do you know what the products will be? Well, for one thing, if it involves an acid and a base, you should already know it's going to produce water. But what about the salt? One technique is to think of the reaction as a full ionic equation, imagining that each reactant separates into its respective ions. So here are the reactants. Positive ions are attracted to the negative ions and vice versa. And if you're wondering why they just don't remain where they are, it's because they have a greater affinity for the other ion. And essentially they're already in solution, so they're already dissociated. This means that these are our products. Acids can also react with metal oxides or amphoteric oxides. Amphoteric just meaning the substance can act as an acid or a base. So let's look at sulfuric acid and zinc oxide. Once again, just imagine the reactants as dissociated ions and rearrange them to produce the products. So the balanced chemical equation is this. Acids can also react with carbonates. These are substances that contain the carbonate ion bonded to a cation. These produce the salt, water, and also carbon dioxide. For example, when hydrochloric acid reacts with calcium carbonate, which is essentially marble chips, you produce the salt, calcium chloride, water, and carbon dioxide. Remember how it fizzes in the test tube? Imagine the reactants as dissociated ions and jumble. If reacting with the hydrogen carbonate ion, the products are still the same. Just need to do a little bit more balancing. The final acid reactions involve metals. Essentially, they always produce a metal salt, that is, the positive ion of the metal with the anion of the acid, and hydrogen gas. For example, hydrochloric acid and zinc. Once again, imagine the reactants as ions and just do the old switcheroo. It's worth noting though that metals, assuming that they don't have an oxide layer, tend to only react with acids if they are above hydrogen in the reactivity series of metals, as in the metal must be able to displace the hydrogen ion out of solution. So gold, being highly unreactive, should not react with most acids since it's below hydrogen in the reactivity series.